So honestly, I didn't expect so many people, so we are almost 40 here. Okay, chat is available here in Zoom, so you can send me your questions and your comment using the chat. So I hope everybody found the chat. Okay, so let's start. My name is Chilar. I'm from Chromatech. Here with me from Chromatech, Mr. Valery Korobov, our application specialist for natural gas analysis, and Mr. Nikolai Protasov, our service engineer. Today we are going to discuss the natural gas analyzers, how we can make configuration for natural gas analyzer, and I hope today's webinar will help you in future to provide a needed knowledge for any gas analyzer. So you will have a good understanding how natural gas analyzer works and how to make a basic configuration for any gas analyzer in principle. So okay. So let's start. So natural gas analyzer. So let us start by full understanding what is the natural gas exactly. So natural gas or fossil gas, it is a naturally available mixture of gases which are rich in hydrocarbons. So it is available in deep underground, and please, okay, don't mix it up with LPG or petroleum gas or any other gases. Okay, I think it's easy. So, here in this table, we can see the typical and the range of main components of the natural gas. So we can see that natural gas primary consists the methane. So methane is the main component of the natural gas. We can see other hydrocarbons and some permanent gases like CO2, nitrogen, oxygen, helium, hydrogen, and some sulfuric compounds. Okay, people still arrive. So it's a nice picture here to see that different gases gives us different color of flame. So of course some gases are not produce any energy during burning. Some gases produce very high energy. So we can divide all gases to energy components and non-energy components in the natural gas. So I hope it's clear. So let's talk about the uses of natural gas. So I think, okay, it is clear that the main use of the natural gas is a fuel gas, just as a fuel for combustion. So to produce electricity or for cooking or heating or to use it for cars, for transportation. And the main or the majority of the natural gas analyzers are dedicated for this proposal. But in addition, we have some other fields where natural gas can be used. For example, in filterizer industry. We also regularly provide some filterizer companies by natural gas analyzers for measuring their processes to produce the ammonia needed later to produce the fertilizers. Also, I would like to mention that natural gas is one of main sources of methane, hydrogen, and carbon dioxide to use it later for in other industries. Natural gas is the main source of helium. So, for example, in some natural gas plants, the helium percentage could be relatively high, 2–3%. And the helium will be extracted from natural gas to be used later for many reasons. So one of common question we have, especially from people who are beginners in chromatography, is why we need a special analyzer for natural gas. Why cannot we use a natural gas, why we cannot use any normal GC for natural gas analysis? So here we should mention that we have the different challenges or two sides of the challenges. The first one is related to the hardware. Here, the first problem that in separation of natural gas components. Natural gas, if you remember, contains many different compounds. And these compounds are very different, and we cannot separate them easily using one column. It is not like, for example, fatty acids or pesticides, because all fatty acids are the same class and can be easily separated using one column, or pesticides can be separated using one column as well. But in natural gas, we have a big variety of compounds, and we need different solutions to separate them all in one system. Additional problem we have in natural gas, it is the carrier gas choosing. If we will use helium as carrier gas, it will be difficult to measure the helium in normal GC. Or if we use hydrogen or nitrogen as well, so we cannot easily measure nitrogen and hydrogen in this order, because the natural gas sample will be mixed with the carrier gas. Another hardware issue we have in normal GC is determination. So different components of the natural gas needs different techniques to be measured for determination. For example, we need a TCD detector to measure oxygen, nitrogen, helium, and we need a FID detector to measure hydrocarbons. In addition, we should add that we have a big variety in concentration. Some components can be in trace level, and some components, like methane, for example, can reach almost 100%. So the other side of the challenges in the natural gas, that the many operators or users of the natural gas analyzers, they don't directly interest in the composition of the natural gas. They don't need the concentration of CO2 or for propane or isobutane. They need just to know uh, directly, is this gas okay, good or not good, to know the thermal or heating production of this gas. Okay, by another words, the NGA, Natural Gas Analyzer, provides additional calculation to based off gas composition, of course, to measure the thermal and physical properties of gas. For example, the calorific volume in megajoules, kilojoules, or BTU. So BTU or megajoules, kilojoules, it is the unit to measure the capacity of heating or cooling. Because if they use the natural gas for combustion, so they can increase the volume of natural gas or to reduce it to reach the needed amount of the heating or the needed capacity of heating. Okay, let's continue. So, in other words, okay, what is the natural gas analyzer? So, natural gas analyzer, it is not only GC. Natural gas analyzer, it is a GC plus some additional hardware. We can call it engineering solution and some software solution to provide the two following tasks. It is to measure all components of natural gas and to provide all calculation needed to evaluate the quality or the thermal properties of the natural gas. So here we can see different standards of natural gas analysis. So here we can see about 7 standards, and this standards requires different hardware. So you can see some standards needs to measure only up to C6 or C7, C8. Some standards require to reach high hydrocarbon level. Some standards require to measure the hydrogen and helium as well, and some standards requires almost everything. And I want to mention here one important point, that one GC depends on configuration, can meet few standards at the same time. For example, our solution 1103 can meet the GPA 2286 and STM 1945 at the same time. So it depends on the hardware. In addition, we have one a very important international standard, is ISO 6976. This standard provides information needed to calculate the mentioned thermal properties of the gas. So this ISO, it is for software to provide needed calculation later after the analysis, once the analysis will finish. So we can say that these standards are for hardware and this standard is for software. Okay, so Chromatech provides all needed for NDA in one solution. So we can configure the GC according to the needed standard or based on the analytical task. So we have Chromatech analytic software to drive the GC, and in addition we have Chromatech gas software. You can see it is according the ISO 6976 to provide the additional calculation needed for the natural gas. So I will show you later, okay, the Chromatech gas software as well and Chromatech analytic also. So before start talking about Chromatech solutions, I want to show you some. So we have this table. I think this file is very useful. So here we can see different analyzers available from Chromatech and which standard each analyzer meets with reference. So let me send you this file later. So here, because you can find concentration ranges, the needed hardware, so you can see here the methods, and this number, it is the solution number in Chromatech. Okay, now I want to switch to another presentation, then I will back to this presentation and talk about Chromatech analyzers. But I want to share with you another presentation about the hardware engineering of the natural gas. So any questions for at the moment? Okay, if you can hear me, also okay, please send me any symptoms of life. Yes, of course, I will send you this Word file. It is very useful to understand our basic or standard solutions. So these solutions in the Word file, it is already created, tested, and we can do them relatively faster than any customized solution. Because maybe the customer needs something in addition, so in this time it will not be one of our standard solutions, so we may need some additional time for them. But for natural gas in our portfolio, we have 8 ready solutions to meet the main standards in natural gas analysis. So I will start now one presentation. Yes, Pradeep, please. So I can see you have a question. Please type your question in chat. You have no sound. Okay. Okay, let me check. Okay, what can I do? Okay, so I want now to start this important presentation. So I prefer to not share this presentation with the customer. It is nothing secret here or nothing confidential, but just because it is a little bit difficult for customer understanding, uh, but it will help you to understand the configuration principles of the natural gas. So we will now start talking about internal hardware details of the natural gas analysis. So roughly in one picture, we can say that the natural gas analysis provides simultaneous injection of natural gas sample to different analytical channels. It could be one channel, two channel, maximum we can provide 4 channels. We'll mix it with carrier gas or with carrier gases and provides simultaneous detection of natural gas components. For example, this channel will provide for first 5 components, this channel for next 5, and this channel number 3 will provide determination for other or the rest of components. So it depends on configuration. We can have different channels, and the inside part of each channel can be different. So again, let me here repeat that we inject the same natural gas sample to 2 different channels. We don't apply any pre-filtering or pre-separation before the GC. So this is our GC here around, and we inject the same sample to different channels. So what exactly we need for natural gas analyzer? So of course, at least we need one GC. Then we need a valve or valves with sample loop, small wires to inject the gas sample to the GC, because we cannot inject gas sample using syringe. To switch between different columns or to provide backflushing, venting, or by other words, cleaning of the line, we need some additional switching valves. We need flame ionization detector for hydrocarbon detection and TCD detector for gas detection. I think everybody knows the principle of FID and TCD. So if you need any details about FID and TCD separately, we can discuss it later. So, but in few words, okay, for just to reach all participants in our webinar. So FID based on flame ionization, so it can detect all components what can be combusted, for example, hydrocarbons. TCD compare the thermal conductivity between the target compound and the carrier gas. So thermal conductivity we can use for gas detection. But in addition, we can use TCD for methane and ethane detection, because we have high concentration of both. Here it is almost 90%. Here it is almost 10% or maybe a little bit. So FID, it is more sensitive, and in FID we can reach ppm range. Meanwhile, TCD can work in percentage range. So to save our time, to save our line, so we can use the TCD as well. Optionally, to detect the methane and the ethane as well. So we need a few columns because we have different channels, so we need more than one column at least. We may need some additional valves for system stabilizing. We can optionally add a splitless inlet, some flow and pressure regulators, and some other accessories, depends on the configuration. So let's start talking about valve working. So we use valve to inject the sample, the gas sample to the GC. So it's valid not only for natural gas, so we use the same principle for sampling of refinery gases or any other gas in principle. So here we can see 6-port valve. It has 2 positions, A and B, and we can see in position A, so here in position E, so we can see that sample comes, fills the sample loop. Sample loop has exact volume. For example, I can choose sample loop 1 milliliter, 2 milliliters, or 500 microliters. So sample comes, fills the sample loop, and then goes to the waste. At the same time, carrier gas comes and provides some gas for conditioning or for venting my column. After valve switching, so the carrier gas, so you can see after switching, the position 4 and 3 will be connecting, 2 and 1, 6 and 5. So after switching the valve position, the carrier gas will come, push the sample out from the sample loop and carry it to my analytical column. So I can recommend you to visit one very useful website here in which is our partner for valves. So here you can see different application of valves. So now we were talking about sample injection. So I will choose sample injection. So you can see here different applications. So here we can see how exactly the valve, gas sampling valve, is working. So I think it's clear. No questions here regarding the valve working. If you need this link, I can copy it to the chat. So can you see my link in the chat? Okay, what if I want to provide injection to more than one column, for example, for 2 columns? So I can use two 6-port valves. So here I will connect another valve in series to the previous one. So this valve will provide injection to column 1, and this valve will provide to column 2. I can add here also, if needed, another valve, and I can inject to 3 columns. I can add another valve and inject to 4 columns if needed at the same time. But actually we have another option here to inject to 2 different channels or to 2 different columns. I can use one 10-port valves. It is much cheaper than 2 6-port valves, and only one switching needed here. So you can see here how 10-port valves work. So we have here 2 different carrier gases. Carrier gas 1 takes the sample from sample loop 1 and send it to column 1, and carrier gas 2 takes it from sample loop 2 and send it to column 2. So sample loops can be different for depends on columns and detectors we have. So if we need a higher sensitivity, we can increase sample loop volume. Or if peaks are very big and we need to reduce the sample, we can use a smaller sample loop. So we can also see a nice video available on Vichy website about how to provide simultaneous injection of the same sample to 2 separate columns. So sample fills the loop 1, then fills the loop 2. So blue is my sample, gray is my carrier gas or gases. So then after switching, carrier gas pushes my sample from sample loop onto column. Okay, please visit this website. Here you can find different applications regarding the valves, and please keep in mind that we use only 6 ports and 10 ports valves in our NGA solutions. So we don't use 4 ports or 8 ports valves anymore. So to make any configuration of NGA, we should start with 10-port valves. So these 10-port valves with 2 sample loops, 2 carrier gases, will provide injection to 2 different channels. One channel I can use to detect the gases, and another channel for hydrocarbon gases. So let's start from the difficult part first, and then we will talk about the easiest part. So let's talk about channel for gases measuring. So the typical solution for almost all of our natural gas analyzer looks like this. Okay, don't be scary. So here we connected our sample to double valve solution with 2 columns. We have here additional flow for switching and 1 TCD detector. So let's take this part and talk exactly how does this part work. So I will ignore now, okay, the hydrocarbon channel and sampling part, and I will talk how exactly this part provides analysis of gas. So natural gas sample comes from the gas sampling valve. If you remember, it was 10 ports valve. And what I have here, I have one high SEP packed column and I have another molecular sieve column. So if I will connect the detector directly to the high SEP, and I will provide injection of my natural gas sample to only this column, I will see a chromatogram like this. So no separation of oxygen, nitrogen, methane, and CO. But good separation for CO2, ethane, and H2S. I will explain later why we use here auxiliary oven, not the main GC oven. Okay. We don't need here any high temperature or programming, so we use auxiliary oven. I will explain in details, okay, a bit later. So this column provides a separation like the picture we have here. So what we can do here, after passing of these compounds of the first column, they will go to the next column. And what we can do here, we can block them inside by switching this valve. So it means that these compounds will be blocked here like in jail. We will put them in the jail, but the sample from here, after we will provide switching here, and samples from here, starting from CO2, will go directly to the TCD. So let me repeat again. So we will take the compounds weren't separated and block them inside this column by switching this valve. So I will make the valve switching exactly here. So here is it's switching time. These compounds will continue going without coming or without going to packed column 2. Then after appearing of ethane, or I can continue until H2S appearing. I can switch this valve again, and this column will provide separation for the oxygen, nitrogen, methane, and CO. Let us see the resulted chromatogram. So we can see that CO2 and C2 appear first because they went directly from column 1 to the detector. Other compounds were blocked in the column 2, and we switch it again after appearing of, maybe here we can, if we don't need H2S, or we can provide the switching back of this valve here to have the oxygen, nitrogen, methane, and if we have CO, we will see it here. I want to mention that CO is not common for natural gas, because CO is a result of combustion. So, and CO shouldn't be inside any natural gas. But according to many standards and in many our solutions, we provide measuring of CO if needed. So let us summarize this channel. So this channel provides measuring of these gases without detection of hydrogen and helium. We cannot measure them because the column configuration doesn't provide separation of hydrogen and helium. In addition, we should use hydrogen or helium as carrier gas for this channel, so we cannot detect them as well. So for 2 reasons. So I know it's a little bit complicated, but believe me, it is the most difficult part in the NGA. So do you have any questions here? So this channel or this solution for gases is used for almost all our analyzers. So if no question, I can go to the yeah, of course. Here is the same. So here we have a question about the quantification. So if we will look later to the software, and we will see that, of course, we have calibration gases, and we should inject a known concentration for each component and make a calibration table. At least we need 1 point calibration for natural gas for each one. Here's a standard approach for like NEGC system. Okay, here a question about how this gelling is happening. No, gelling is happening because it's an important question, so let me explain it a little bit in details. So we provide injection of natural gas sample. So oxygen, nitrogen, methane, and CO2 will pass this column very fast, and they will reach the second column very fast. At the same time, CO2 and C2 and H2S still in the column 1. In this moment, when these components inside this column and this component still in the first column, we switch this valve. Switching this valve means that this channel will be connected here. This channel will connected here. And this channel will be connected here. So we provide real physical jail of components inside the column. So the column, both ends of the column will be linked to get together. This and right here, the column connection after valve switching. Because here in the picture, we can see only one valve position. So we switch this valve and CO2 and other compounds then will come here. They will come easily and they will go through the needle valve to TCD. And I will see, let's see next picture. So I will see on chromatogram the CO2 first. CO2 first, then ethane. If I have H2S, I will see it. Then I make valve switching again. So, and carrier gas will come and push my oxygen, nitrogen, C1 and CO from this column to TCD detector, and I will see them in this order. Okay, but is it clear now, Abed? Okay. Why we need this needle valve, or what is the function of this needle valve? The needle valve, it is a part to provide some pressure resistance, because in position A, for example, we have a packed column here. After switching, this needle valve should apply the same pressure resistance like the column to make the system stable, because if we don't have any needle valve here, the pressure on this line will drop down and the baseline will jump, what is not beautiful. As alternative, many manufacturers use restricted columns, part of or small part of capillary column to create the same pressure resistance of the packed column, but we prefer to use needle valves because it is very easy to adjust using just a screwdriver. So let me repeat again, needle valves, it is additional accessory needed to apply the same pressure resistance like a column on other side of valve during the switching. So it means we will have the same pressure here even after and before valve switching. So this is the function of the needle valve. Here as well, we have the same function of the needle valve. Okay, so can I continue now? So this channel is more or less, I hope it's clear. So let's talk about channel 2 for hydrocarbons. It is much simpler. So channel for hydrocarbons, it is typically capillary column to provide a separation of hydrocarbons. To accelerate the process of hydrocarbon separation, we need to apply a temperature program. So we will locate our capillary column inside the main GC oven. Optionally, we can add splitless inlet. Actually, we prefer to have it because you can use this channel for liquid injection as well, using syringe if you have any liquid hydrocarbon mixture or to make some tests of the system. So you can make liquid injection to the inlet as well. So I think it's very simple here. So what exactly we have? So here, if we will talk in details, so carrier gas could be helium, typically helium because we have a long column here. So we typically need a non-polar column to separate hydrocarbons. Depends on needed application, we can use different lengths of the columns. For example, if we need up to tetradecan, I mean C14, we need long column, 60 meters. If we don't need so high hydrocarbon number, we can use shorter column. So this is a typical chromatogram of hydrocarbon channel. So you can see here that we didn't provide separation of methane and ethane. We can, of course, change the program of the oven and try to have a good separation of C1 and C2, but it will make the analysis very long. So we prefer to ignore here the methane and ethane and take them from the previous channel, from here, because both are available on TCD. So we have high concentration of both, so and TCD is enough to reach the needed concentration. So for some analyzers, not for the GPA 2286, we can have another or alternative solution for hydrocarbon channel or solution with backflashing. So we know that our hydrocarbon fraction has hydrocarbons starting from C1 until high hydrocarbons, C10, C12, C14. Typically in room temperature, hydrocarbons from C1 to C5 are gas. So let us call them light hydrocarbons, and hydrocarbons start from C6 are liquid, so let us call them heavy hydrocarbon. So in this configuration, we have two columns. One pre-column, very short, 2, 3, 5 meters, depend on configuration, and long or main capillary column. So what is happening here? After injection of my hydrocarbon mixture or a natural gas sample, light hydrocarbons will pass the pre-column very fast, and then they will reach the main column. At the moment when light hydrocarbon have reached the capillary column 1, but heavy hydrocarbons are still in the pre-column, I provide the valve switching. And what is happening here in this case, let me connect here everything just to have. In this case, carrier gas will come to my column and main column, and from main column it so I will sorry. So I provide here two switching. One switching to send back the all heavy hydrocarbons were here. So here I have a heavy fraction, and this heavy fraction C6, C7, C10 will not be separated because column is very short, and it will be sent to backflash very fast. Then I will switch the column again somewhere here, and the carrier gas will push my hydrocarbons out to the FID in the typical order or based on the hydrocarbon number or carbon number we have. So this solution provides faster analysis for hydrocarbon channel, and for many standards it is required. So if you remember from the previous presentation, for example, for some standards we need C6+. Again, C6+, it is all hydrocarbons starting from 6, 7 and higher as one single peak using the backflashing. So let us summarize what we have. So we have 10-port valve with 2 sample loops. Here we have a channel with 2 valves and 2 compact columns to provide separation and determination of the natural gas components. Of course, here we can use bigger sample loop, maybe 0.5 milliliter. Here, for capillary column, we don't need a big sample loop because capillary column volume is limited, so we can use smaller, for example, 0.2 or 0.1 sample loop. So this channel provides measuring for gases. This channel provides measuring of hydrocarbon. So before continuing, do you have any questions here? If not, I will continue now. Okay, so typically pre-column for hydrocarbons. So let me back here. So typically here for hydrocarbons, we use the same column. For example, the BP1. But here it is shorter, here it is longer. Sometimes, of course, depends on, it could be different between natural gas and refinery gas, because here we have a higher concentration of methane. So we can use, for example, here BP5 and here BP1. Depends on how fast you need the analysis. So the hydrocarbon separation is happening in capillary column. So we definitely have a good separation of all hydrocarbons in capillary columns, because capillary columns provide very good separation. Okay, one important question here from George about NGA and RGA. So RGA, it is the refinery gas analysis. So for RGA, we have no any change typically for this channel, because we have the same gases in RGA. But in RGA, we definitely will have CO, because RGA it is resulted of some thermal effects for reforming or for catalytic comes after catalytic reactor. So we will have definitely CO in RGA. So this channel is almost the same for RGA. But it is a big difference for natural gas, for hydrocarbon channel between RGA and NGA. Why? Because, let me back to this, to the composition of natural gas. So you can see that in natural gas, we have alkanes. Let us look to the hydrocarbons we have. I mean saturated hydrocarbons. Nature, in general, okay, don't take it as a rule, but roughly, okay, we can say that natural has no any unsaturated hydrocarbons. I mean, we don't have any ethylene, any propylene in nature. So natural gas doesn't contain any unsaturated hydrocarbons. But in RGA, we have a lot of ethylene, propylene, and other unsaturated hydrocarbons what are not available in natural gas. Therefore, The hydrocarbon channel for RGA will be completely different. Normal capillary column BP1 cannot provide separation of all isomers of saturated and unsaturated hydrocarbons. So I need to change this column by a double or system of columns, including a plot column. It is more expensive, but this plot column provides separation for both saturated hydrocarbons and unsaturated hydrocarbons. This is the main difference between the MGA and RGA analyzers. Of course, we need different filtering in beginning of analysis for MGA and RGA, but it is another story. So we will talk about RGA in one of our next meetings. Okay, I hope so. So this is in few words about the difference between RGA and RGA. So this is one of we have now this picture. It is already analyzer, and this analyzer meets too many standards. But what if we need hydrogen and helium as well? Especially we need hydrogen and helium also for RGA. For many standards, we also need to measure helium and hydrogen. So it means we need some additional channel. So we will connect one channel more to our sample path. So finally, it looks like this. So I have added here this part. It is very simple, but I kept it to the end because it's optional. The gases and hydrocarbons, it's essential for any natural gas analyzer. Helium and hydrogen detection, it is optional for natural gas. It's essential for refinery gas. So you can see here we have one valve with sample loop to make the injection, and another TCD detector. But be careful here. We need here to use another carrier gas. You can see here. So we used here helium and or hydrogen. Here we need to use argon or nitrogen as carrier gas. One of the benefits of different carrier gas, it is the difference in the thermal conductivity. Oxygen, nitrogen, and even argon, they have very similar thermal conductivity, so we cannot reach very good detection limits if we have the same carrier gas and reference gas in the TCD, if we use similar thermal conductivity. But it is very big difference between helium and hydrogen comparing to oxygen and nitrogen in thermal conductivity. Here we have the opposite situation. So we use nitrogen also with very far thermal conductivity from hydrogen and helium. So we use here very simple column. It's molecular sieve column with 5 angstrom mesh. It's the size of meshes inside. This column is typically similar to column we use here. So it's typically the same. So it's very easy principle here. The smaller molecules will pass the molecular sieve faster than others. And helium will appear first, then we will see hydrogen peak. Then I don't need to wait for other components, okay? Please remember, we still have oxygen, nitrogen, a lot of hydrocarbons. And if we will wait all of them to pass the molecular sieve, it will take a very long time. So this is the reason why I have here 10 ports column, not 6 port columns, to provide a backflashing to send the all other components still in the sample back to vent. So this channel provides measuring of helium and hydrogen, then backflashing to vent all unwanted compounds out to the TCD. Okay, so it was a detailed explanation of one of most popular natural gas analyzers. Sorry, what exactly do you mean? What about multiply samples? Can you please clear your question, Mr. Ho? Yeah, okay. I will show you later what solution we have if we have more than one cylinder. So typically, I should connect first my calibration standard, inject it as a calibration. I can show you here in analytic software. So this is, you can see this sample was injected as calibration. So here and in component, I will put the concentration because it is noun sample. So later I can apply this so you can see here for each component we have single point calibration. Of course, I can apply 2-point calibration if needed. It depends on standard you use, the customer demand, and the range of the concentration you expect to have. Okay. I haven't finished yet. I haven't finished yet. So I'm finishing only this presentation. So we will continue our previous presentation. Okay, then I will share some questions and common questions regarding the NGA. So let me back, okay, here to our to my main presentation for the natural gas. So as I told you, we have all needed from one source, GC, software to control the GC, and software to provide all needed calculations after finishing the analysis. So this is one of our solutions, for example. So you can see here some description of this. So this is a 3-channel system. It is similar to that one we had. We made the configuration together. So we have here 2 TCD and 1 FID. So let us talk about some features we have in our natural gas analysis. So we have full flexibility to choose the carrier gas we need. So we can use argon. It is also a good advantage because many GCs cannot use argon as carrier gas. People who knows the pneumatic design and electronic design of Chromatec can evaluate that the system can be easily modified to reach the needed tasks with really lower price comparing to any other brand. This is one of our main advantages, that design is very flexible. We don't have any merged part together, any merged pneumatic systems together. We have independent line for each gas, independent heating zone for each part. We can put 2 TCDs, 3 TCDs together on the same line in the same heating slot if needed. We can separate them if needed. So we have full flexibility in design of the system. In addition, I can say that we have some natural gas and refinery gas systems with 4 channels, not only for 3, but as well for 4 channels. I can show you one if you want, or not. This example now of for example, this system, this is for catalytic reactors measuring. It was installed by FAES in France. So you can see here that we have 4 detectors, 4 channels, 2 TCD and 2 FID. It was one of advanced solutions provided by Chromatec, and it shows the flexibility in design and how easy it was to connect all needed valves at the same time. It meets the customer budget. Yeah, so let me continue my presentation, and I will answer to your question, okay, Mr. Sitiaupam, okay? This is okay, our partner in Indonesia. So let me continue here. I would like to mention one important point again, that our system can be protected from any aggressive gases or sample. For example, we can provide self-inert line, we can provide a nickel-coated line, we can provide a special material like Hastelloy C. It can stand even for pure chlorine sample. In addition, I want to say that we have all our electronic parts are coated by a special material to save them from any effect or from any reaction with the ambient air around the system. So we expect a longer lifetime for all our electronic thanks to this special coating. One of our advantages as well that our software initially was created for oil and gas industry. So it easily can understand the signals from 4 detectors. No need to provide some additional plugins like a bridge connection to link different signals from different detectors at the same time. So software automatically understands the signals from all detectors we have. We can apply any needed calculation based on customer request. Sometimes we can do some changes in the software to meet some special customer demands. One of our serious advantages that we can provide 2 types of valves, Vichy or Falco valves, or our own chromatic valves. Depends on the application we have. We provide one of these valves. So in addition, I want to say that we have very wide range of accessories because Chromatech accumulate a very serious experience in natural gas analysis, especially here in Russia. We have the biggest natural gas companies, and we have our own original accessory range, and we deal with any company, even with Agilent, even with Restake, we can to meet the customer demand. We are ready to buy any needed material from the best companies to provide the better solution here. One small slide about LNG or liquefied natural gas. So as I told you, natural gas, it is mainly methane. Methane cannot be easily liquefied. It's not like LPG. LPG, I can apply some pressure, I mean petroleum gas, and it will be liquefied. It will become liquid. But natural gas needs very low temperature and very high pressure to be liquefied. Typically, the LNG is useful for natural gas transportation by special ships. Because there are 2 ways for natural gas transportation, using pipelines. But in pipelines, we use natural gas as in gas phase or in ships. But here we have a limited volume, so the LNG is the best way to transport the natural gas by ships. But if we want to make analysis of LNG on the GC, we cannot inject directly LNG to the GC. It is impossible because we need very special condition to keep the liquid natural gas as liquid. So we need to vaporize it to convert it back to gas and inject it directly to the GC as gas sample. One specific point for LNG that typically for LNG, we don't need to measure all other compounds. We need to measure only light hydrocarbons and nitrogen. Why? Because if we will see the I'm sorry. So if we see in that before transportation of liquefied natural gas, we remove CO2 to save the space in the ship. CO2 is not useful here. Also, heavy hydrocarbons are removed in liquefied natural gas. Again, just to save the space. So typically for LNG analysis, we need to measure only hydrocarbons, light hydrocarbons, and nitrogen. So let me see here in chat if you have any questions. Okay, let us talk about some other accessories, okay, I can use. So I can add LPG stream vaporizer. It's a special accessory to inject LPG to natural gas analyzer. It is like additional option. Of course, it will not work as a full LPG analyzer, but it can help to measure roughly the hydrocarbons in the LPG. Of course, without measuring of unsaturated hydrocarbons. So LPG stream vaporizer provide vaporization of liquefied petroleum gas to gas phase, which is very gentle vaporization to save the concentration, the ratios between compounds in the LPG. It is very gentle heating here we have. And then sample with a special valve will be sent to the natural gas analyzer. So you can see here a chromatogram of LPG on natural gas analyzer. So we can see we have almost no gases, but we can see the main components of LPG, propane, isobutane, and normal butane. So additional accessory we can provide with the natural gas analysis is a sensor to detect the helium, the hydrogen leak, because hydrogen leak inside the oven can be dangerous. So this sensor will detect the leak, and we can see here we have a special additional valve here. So hydrogen comes to this valve, and from this valve it will go to the GC. So in case of any leak inside the GC, the sensor will stop the hydrogen flow to the GC. So I had a question how to deal if we have many cylinders, or maybe I will locate my natural gas analyzer beside a few pipes with different streams of natural gas. So optionally we can offer a stream selection, and we can program it from the main software. It will work automatically, and we can create a sequence. For example, take sample from cylinder 1 or stream 1, make 2 analyses, then take it from cylinder 2 or stream 2, make a few analyses, and we can easily program or swap between different streams we have. In addition, we can add the flow sensor, and if the cylinder will be empty, for example, the software will inform us that no pressure here and no flow, and it will stop the analysis. So it is fully integrated in Chromatech analytics software and easy to control. So some other function or some other solutions in addition we can provide, it is to combine natural gas and sulfur analysis. So here if we have TCD and FID, we can add PFPD detector or additional channel to measure the carbonyl sulfate H2S. It is in very low concentration, and mercaptans, methyl and ethyl mercaptans in the natural gas according to ISTM 6228. We have also our product line of sulfuric analysis. If we want to make a detailed analysis of sulfuric compounds, we can make different solution based on FPD, but of course FPD is not for low concentration. So we can use it for natural gas after odorization. We can call it town gas, because natural gas before coming to houses, some mercaptans is added there to make it smell for safety reason. So we can use GC based on FPD to measure the sulfuric compounds if needed. So this is just okay for your information. So this is another sulfuric analysis with double FPD system with 2 channels here, and we can reach here very low concentration up to 0.1 ppm for natural gas samples. So also for your information, we have a portable natural gas analyzer. It is much simpler. We can have here 1 TCD or 2 TCDs or 1 FID, depends on application. So it needs ISO 6974 with the same software and short analysis time. So you can see here that we provide as well the cage to handle it, a battery to keep it working without power, and we have also here a space for the laptop. Actually, the natural gas analyzer is available in 2 modes, like in a portable one and in 19-inch rack mode as well. So let me answer to one of your questions in the chat. Yes, of course, we can provide a wide range of customized NGA or gas analyzers in general, because we have a lot of reasons to say that we can do it better than any other company, because we have the most flexible GC system and a wider range of accessories needed for gas chromatography analysis. So I see one question regarding the software, how the software works. So I have Chromatech analytics software. Chromatech analytics software, it is the basic software to control the GC and to save the data, to handle the data. So let me show. So this is my Chromatech analytics software. It provides basic calculation. It can calculate the concentrations, make simple reports based on areas, highs, concentrations. And of course, it can control and drive the GC. So it has online part and offline part. So here we have many options for reporting. We can save it in different formats here, or we can see here the chromatography report. So here in chromatography report, I will see that, okay, I have component list with general chromatography information, like concentration, like chromatograms. I can add here some general chromatography information. I can customize this report, but this Chromatech analytics software will not provide you additional calculation like BTU or megajoule. So let me show you the another software. Once all components will be detected here in this software, actually it will be done automatically because it will be set up before. So you will have your result. So we need to open Chromatech Gas software. So it is a separate software. So this is the Chromatech Gas software. It is a smaller software. So I can calculate gas properties according to the mentioned ISO method before. So I can just choose the needed sample. For example, let me take this one. So here I can see some general settings, how to set the font, some additional comments if needed. So different units of energy. So I can set up here my calculation, and then the software just by one click will provide this additional reports. What we have here. So based on concentrations we have, the software will provide physical and chemical parameters according to the ISO method. So for example here, so I have a composition based on molar composition, volume composition, and mass composition. So here I can see the molar mass of the gas, compression factor, and calor and the heating all calorific value. Of course, I can print it from here. So it's 2-page report. I hope you can see it. Okay, I can send you an example of this report if you want. Just, okay, let me by email. Let me see another example. For example, we can use this software even for LPG, because we will take the hydrocarbon composition of LPG. So this is the LPG composition. So we can see here that it is mainly propane. And we can see here the additional parameters calculated using the Chromatech Gas software. So how does it work exactly? So it takes the composition from Chromatech analytics software, and then we have here internal library. So we can see here that the library matches the name in Chromatech Analytic and the name we have in the library, and the library provides our initial parameters or raw information needed to provide the additional calculation for hydrocarbon for natural gas properties calculation. Okay, so it was our chromatic gas software. So chromatic gas software is a separate software and it should be ordered separately. Yes, of course, George. Okay, thank you for your question. Uh, of course, we can make a template with the customer based on customer wishes. For example, add logo, change the view of report. At least in analytic software, but I'm not sure if we can do it in chromatic gas till now. So we can ask, okay, our IT specialist if we have a flexibility in chromatic gas. In chromatic analytic, we have flexibility in reporting, but I'm not sure if we have it in chromatic gas software. So let us ask about it. Um, So I will ask, okay, because we have released a new version of chromatic gas, so it is a new version. So I don't know, maybe if Valera can join us and help to this question, if we can change the view of natural gas report. What about STM 3588? I really don't know, okay, because I haven't made this request before. So I will forward this question, Valera, to our laboratory. Does software meet CFR 21? Yes, of course, but typically it is not required for natural gas analyzer. We need it for pharmaceutical industry. But yes, of course, our software has a compliance with Part 11 CFR 21 according to FDA requirement. If you need, I can send you a special documents to confirm that. So we spent almost 2 nice hours. Actually, it is my first webinar in such view. So I really thank you all for joining me, for helping me. I hope next time I will be more productive, maybe faster. And if you have any notes, any comments, any recommendation regarding the webinar organization, I really will be happy to know about it. And I am free now, okay, for your questions. If you have any questions or any notes, please let me know. Okay, Bharat, one question for how we can be different. So back to some features we have. So we should talk about, we can talk again about each one, but depends on particular analyzer, we can provide some additional benefits. So it exactly depends on particular solution. For example, for GPA 2186, we have more benefits comparing to 2261, for example. So every depends on configuration, depends on the solution. But in general, I can say that our system, more flexible software, is more flexible to deal with multi-channel analyzers. Plus we have a better sensitivity for FID. So we should talk here about each analyzer and each competitor. So we can arrange later some sales meeting regarding the gas analyzers in general and talk about it. And I want to keep this webinar now only for technical overviewing of the natural gas for better understanding for natural gas. A question about LIMS software. We can send the data automatically to any LIMS software because software can automatically save the data in different formats. But we don't have a driver to control the GC from any LIMS. So LIMS will accept the data from our GC, from our software, but LIMS will not drive it. So we need to use our software to drive the GC. So please send me an email if you need the recording, the presentations, and examples of reporting and data. Please send me an email. I will send you back a link to download all data and reports. So thank you again. And I hope to see you all in our next training in Russia. Okay, take care and be healthy. Okay, wishes the best for you and your families. Take care and bye. Thank you again. Bye. Yes, sure, please send me an email and I will send you the recording, I will send you the presentation, example, data. Just, okay, remind me, okay, on my email. And I will send you all materials needed for this. Thank you very much, and goodbye.